Hello. Just give me 1 second. All right. We are going over object-oriented programming with Free Code Camp today. No? Yeah? Okay. Need to get a drink. Get my drink on before we get started. All right, let's create a basic JavaScript object. Think about things people see every day, like cars, shops, and birds. These are all objects, tangible things people can observe, and interact with. What are some qualities of these objects? A car has wheels, shops sell items, birds have wings. These qualities or properties define what makes up an object. That similar objects share the same properties but may have different values for those properties. For example, all cars have wheels, but not all cars have the same number of wheels. Objects in JavaScript are used to model real-world objects, giving them properties and behavior just like their real-world counterparts. Here's an example using these concepts to create a duck object. So we have a duck, it's an object. We're using those curly braces. Its name is Affleck. It has 2 legs. This duck object, excuse me. This duck object has 2 property value pairs, a name of Affleck and a num legs of 2. Create a dog object with a name and numLegs properties and set them to a string and number respectively. So boom. Ugh. Use dot notation to access the properties of an object. The last challenge created an object with various properties. Now you'll see how to access the values of those properties. Here's an example. We have duck, same duck as before, and we're logging out the duck name, so we get Affleck. Dot notation is used on the object name, duck, followed by the name of the property name to access the value of Affleck. Print both properties of the dog object below to your console. Dog.name, and we'll just copy this and change it. Create a method on an object. Objects can have a special type of property called a method. Methods are properties that are functions. that are functions. This adds different behavior to an object. Here's the duck example with a method. Here, so we got the duck, but now he has a method, and it returns its name. Duck say name. The name of this duck is Aflac. The example adds the say name method, which is a function that returns a sentence giving the name of the duck. Notice that the method accessed the name property in the return statement using duck.name. The next challenge will cover another way to do this. Use the dog object, give it a method called sayLegs. The method should return the sentence, this dog has 4 legs. So we have sayLegs. I think we can do it the ES6 way. So return this dog has, how about we do this? This dog has legs. What? I need to turn that off. Oh, let's finish the sentence. It's not this dog has 4. There we go. Make code more reusable with the this keyword. The last challenge introduced a method to the duck object. It used duck.name.notation to access the value for the name property within the return statement. A name, we have the function, says the name. While this is a valid way to access the object's property, there's a pitfall here. If the variable name changes, any code referencing the original name would need to be updated as well. In a short object definition, it isn't a problem, but if an object has many references to its properties, there's a greater chance for error. The way to avoid these issues is with the this keyword. This keyword is a deep topic, and the above example is only one way to use it. In the current context, this refers to the object that the method is associated with, the duck. If the object's name is changed to Mallard, it is not necessary to find all references to duck in the code. It makes the code reusable and easier to read. Modify the dog say legs method to remove any references to dog. Use the duck example for guidance. So this dog has this many number of legs. Constructors are functions that create new objects. They define properties and behaviors that will belong to the new object. Think of them as a blueprint for the creation of new objects. Here's an example of a constructor. Function bird. This name is Albert. This color is blue. This number of legs equals 2. This constructor defines a bird object with properties name, color, and legs set to Albert, blue, and 2 respectively. Constructors follow a few conventions. Constructors are defined with a capitalized name to distinguish them from other functions that are not constructors. Constructors use the keyword this to set properties of the object they will create. Inside of the constructor, this refers to the new object it will create. Constructors define properties and behaviors instead of returning a value as other functions might. Create a constructor dog with properties name, color, and number of legs that are set to a string, and a number respectively. Oh, it's supposed to be a dog, not a bird. Oops. Use a constructor to create objects. Here is the bird constructor from the previous challenge. So we have bluebird equals new bird. Notice that the new operator is used when calling a constructor. This tells objects to create a new instance of the bird called bluebird. Without the new operator, this inside the constructor would not point to the newly created object, giving unexpected results. Now bluebird has all the properties defined inside the bird constructor. Just like any other object, its properties can be accessed and modified. Use the dog constructor from the last lesson to create a new instance of dog, assigning it to a variable hound. So hound, let's see here, let hound equal new dog. Extend constructors to receive arguments. The bird and dog constructors from the last challenge worked well. However, notice that all birds that are created with the bird constructor are automatically named Albert, are blue in color, and have 2 legs. What if you want birds with different values for name and color? It's possible to change the properties of each bird manually, but that would be a lot of work. Suppose you were writing a program to keep track of hundreds or even thousands of different birds in an aviary. It would take a lot of time to create all the birds, then change the properties to different values for every one. To more easily create different bird objects, you can design your bird constructor to accept parameters. We have function bird, accepts a name and a color. When we create it, we can pass a name and a color, but they always have 2 legs. Then pass in the values as arguments to define each unique bird, or the default to 2 legs, into the bird constructor. Let cardinal equal new bird Bruce, and he's red. This gives a new instance of bird with name and color properties set to Bruce and red respectively. The number legs property is still set to 2. The cardinal has these properties. The constructor is more flexible. It's now possible to define the properties for each bird at the same time at the time it is created, which is one way that JavaScript constructors are so useful. They group objects together based on shared characteristics and behavior and define a blueprint that automates their creation. Create another dog constructor. This time, set it up to take the parameter name and color and have the property numLegs fixed at 4. Then create a new dog saved in a variable terrier. Pass it 2 strings as arguments for the name and color. Alright, so we need this dot name. Alright. Then we're going to pass in the name and color. And then it wants us to save to a variable named terrier. Okay. We need to do new dog. There we go. Verify an object's constructor with instance of. Anytime a constructor function creates a new object, that object is said to be an instance of its constructor. JavaScript gives a convenient way to verify this with the instance of operator. Instance of allows you to compare an object to a constructor, returning true or false based on whether or not the object was created with the constructor. Here's an example. So we have bird, it's going to equal the function. Same thing. I think it's just getting us ready to do more advanced. Crow new bird is crow instance of bird true. If an object is created without using a constructor, instance of will verify that it is not an instance of that constructor. Create a new instance of the house constructor, calling it my house and passing a number of bedrooms. Then use instance of to verify that it is an instance of house. So let my house equals new house with 5 bedrooms. Oops. And that's it. And then we go my house instance of house. Object-oriented programming, understand own properties. In the following example, the bird constructor defines 2 properties, name and number of legs. Name and num legs are called own properties because they are defined directly on the instance object. That means duck and canary each has its own separate copy of these properties. In fact, every instance of bird will have its own copy of these properties. The following code adds all of the own properties of duck to the array own props. Alright, so let own props. So every property in the duck, if duck has own property, alright, add the own properties of canary to the array own props. So we're going to just do the same thing. So let property in canary, if the canary has the own property, then own props, we're going to push that property. So what it's doing is it just, since canary is a new bird, that bird, Tweety, has its own name and number of legs. So we're just doing a for loop over each property in canary. So it will do it twice, this name and this number of legs. And we get the property here. And then we check if the canary has that property, which is a little silly because it obviously does. We just looked it up. And we push it into this array. Use prototype properties to reduce duplicate code. Since number of legs will probably have the same value for all instances of bird, you essentially have a duplicate variable, num legs, inside each bird instance. This may not be an issue when there are only 2 instances, but imagine if there are millions of instances. That would be a lot of duplicate variables. A better way is to use the bird's prototype. The prototype is an object that is shared among all instances of bird. Here's how to add num legs to the bird prototype. Now all instances of bird have num legs property. Since all instances automatically have the properties on the prototype, think of a prototype as a recipe for creating objects. Note that the prototype for the duck and canary is part of the bird constructor as bird.prototype. Nearly every object in JavaScript has a prototype property, which is part of the constructor function that created it. Add a num legs property to the prototype of dog. Alright, so So dog prototype num legs equals 4. Iterate over all properties. You have now seen two kinds of properties, own properties and prototype properties. Own properties are defined directly on the object instance itself, and prototype properties are defined on the prototype. So you have bird, that's own property, and then this is a prototype property. Here is how you add a duck's own properties to the array's own props and prototype properties to the array prototype props. So we have our own props and then the prototype props. Let property in duck. If duck has own property, push. Okay, so the has own property is any of its own properties, and if it's any other type of property, we're just going to push it into the other one because it's prototype. Add all of the own properties of the beagle to the array own props. Add all of the prototype properties of dog to the array prototype props. So we do a for let property in beagle, and then we do an if beagle has own property and we're passing the property that we have from this loop. And that's pretty easy to remember because it says it right here. So let's see here. Property. Then if not that, yep. Understand the constructor property. There is a special constructor property located on the object instances duck and beagle that were created in the various challenges. Let duck equal new bird, let beagle equal new dog. Console.log, duck constructor is equal to bird, prints true. The beagle constructor is equal to dog, prints true. Note that the constructor property is a reference to the constructor function that created the instance. The advantage of the constructor property is that it's possible to check for this property to find out what kind of object it is. Here's an example of how this could be useful. Function join bird fraternity. Candidate. If the candidate constructor is equal to a bird, return true. If it's not, return false. Since the constructor property can be overwritten, which will be covered in the next two challenges, it's generally better to use the instance of method to check the type of an object. Write a join.fraternity function that takes a candidate parameter and, using the constructor property, return true if the candidate is a dog, otherwise return false. All right. Let's see here. So we're gonna return and we're checking candidate. Constructor is equal to dog. And if it is, true, and if it's not, false. Cool. Change the prototype to a new object. Up until now, you have been adding properties to the prototype individual. individually. Bird prototype number of legs equals 2. This becomes tedious after more than a few properties. A more efficient way is to set the prototype to a new object that already contains the property. This way, the properties are added all at once. So we have bird prototype equals, and then we just set it to a new object, adding all of them. Let's see, that's cool. Add the property numLegs in the two methods eat and describe to the prototype of dog by setting the prototype to a new object. NumLegs is for eat console.log num. Then we have another console.log. My name is this name. Remember this to set the constructor property when changing the prototype. There is one crucial side effect of manually setting the prototype to a new object. It erased the constructor property. The code in the previous challenge would print the following for duck. Fix this whenever a prototype is manually set to a new object. Remember to define the constructor property. See? Find the constructor property in the dog prototype. Understand where an object's prototype comes from. Just like people inherit genes from their parents, an object inherits its prototype directly from the constructor function that created it. For example, here the bird constructor creates the duck object. Duck inherits its prototype from bird constructor function. You can show this relationship with the isPrototypeOf method. Use isPrototypeOf to check the prototype of Beagle. So we can use dog prototype is prototype of Beagle. Yes. Understand the prototype chain. All objects in JavaScript, with a few exceptions, have a prototype. Also, an object's prototype itself is an object. Because a prototype is an object, a prototype can have its own prototype. In this case, a prototype of bird prototype is object.prototype. Oh, excuse me. How is this useful? You may recall the hasOwnProperty method from a previous challenge. The hasOwnProperty method is defined in object.prototype, which can be accessed by bird.prototype, which can then be accessed by duck. This is an example of the prototype chain. In this prototype chain, bird is the supertype for duck, while duck is the subtype. Object is a supertype for both bird and duck. Object is a supertype for all objects in JavaScript. Therefore, any object can use the hasOwnProperty method. Modify the code to show the correct prototype chain. Use inheritance so you don't repeat yourself. There's a principle in programming called don't repeat yourself, or DRY. The reason repeated code is a problem is because any change requires fixing code in multiple places. This usually means more work for programmers and more room for errors. Notice in the example below that the describe method is shared by bird and dog. The describe method is repeated in two places. The code can be edited to follow the DRY principle by creating a supertype or parent called animal. Function animal, animal prototype. Constructor is an animal. We're going to describe. So all animals have a describe. Since animal includes the describe method, you can remove it from bird and dog. The eat method is repeated in both cat and bear. Edit the code in the spirit of DRY by moving the eat method to the animal supertype. Inherit behaviors from a supertype. In the previous challenge, you created a supertype called animal that defined behaviors shared by all animals. We have an animal, the animal prototype eat. This in the next challenge will cover how to reuse animals method inside bird and dog without defining them again. It uses a technique called inheritance. This challenge covers the first step. Make an instance of the supertype or parent. You already know one way to create an instance of animal using the new operator. Let animal equal new animal. There are some disadvantages when using the syntax for inheritance, which are too complex for the scope of this challenge. Instead, here's an alternative approach without those disadvantages. Let animal object.create animal prototype. Object create creates a new object and sets object as the new object's prototype. Recall that the prototype is like the recipe for creating an object. By setting the prototype of an animal to be the animal's prototype, you are effectively giving the animal instance the same recipe as any other instance of animal. Use object create to make two instances of animal named duck and beagle. Set the child's prototype to an instance of the parent. In the previous challenge, you saw the first step for inheriting behavior from the supertype, or parent, animal, making a new instance of animal. This challenge covers this next step. Set the prototype of the subtype, or child, in this case, bird, to be an instance of animal. Remember that the prototype is like the recipe for creating an object. In a way, the recipe for bird now includes all the key ingredients from animal. Duck inherits all of the animal's properties, including the eat method. Modify the code so that the instance of dog inherit from animal. So we would say dog prototype is equal to object create and we give it the animal prototype. So now when we create the new dog, it has the eat method from animal. Set an inherited constructor property. When an object inherits its prototype from another object, it also inherits the supertype's constructor property. Here's an example. A bird. Bird prototype equals object create animal prototype. Duck is new bird. So the duck constructor is animal. Duck in all instances of bird should show that they were constructed by bird and not animal. To do so, you can manually set bird's constructor property to the bird object. Fix the code so duck constructor and beagle constructor return their respective constructors. So we have bird prototype constructor equals bird and dog prototype constructor equals dog. A constructor function that inherits its prototype object from a supertype constructor function can still have its own methods in addition to inherited methods. For example, a bird is a constructor that inherits its prototype from animal. So we have our blank animal here. We're giving it a prototype eat, so all animals have eat. We have our bird. We're making the bird a prototype. The bird prototype, extension of the animal prototype. So, and then the bird prototype constructor we're setting to bird like we did in the last. In addition to what is inherited from animal, you want to add behavior that is unique to bird objects. Here, bird will get a fly function. Functions are added to the bird's prototype the same way as any constructor function. Now, instances of bird will have both eat and fly methods. Add all necessary code so the dog object inherits from animal and the dog's prototype constructor is set to dog. Then add a bark method to the dog object so the beagle can both eat and bark. The bark method should print woof to the console. Okie dokie. Alright, so the dog prototype is going to be equal to object create, and we'll pass the animal prototype. And then the dog constructor is going to be equal to the dog. And then we want to say dog prototype bark not waff. Woof. Alright. Alright, I see. In previous lessons, you learned that an object can inherit its behaviors, its methods from another object by cloning its prototype object. So we have child object prototype equals object trait parent object prototype. Then the child object received its own methods by chaining them onto its prototype. It's possible to override an inherited method. It's done the same way by adding a method to child object prototype using the same method name as the one to override. Here's an example of bird overriding the eat method inherited from animal. You have an instance let duck equal new bird and you call duck eat. This is how Javascript looks for the method on duck's prototype chain. Duck, is eat defined here? No. Bird, is eat defined here? Yes. Execute it and stop searching. Animal, eat is also defined, but JavaScript stops searching before reaching this level. Object, JavaScript stops searching before reaching this level. Override the fly method for penguins so that it returns the last. This is a flightless bird. So penguin, prototype, fly. Alas, this is a flightless bird. Use a mixin to add common behavior between unrelated objects. As you have seen, behavior is shared through the inheritance. However, there are cases when inheritance is not the best solution. Inheritance does not work well for unrelated objects like bird and airplane. They can both fly, but a bird is not a type of airplane and vice versa. For unrelated objects, it's better to use mixins. A mixin allows other objects to use a collection of functions. So we have fly mixin function. We pass the object, and then we set fly on that object. All right. Fly mixin takes any object and gives it the fly method. Here, bird and plane are passed into fly mixin, which then assigns the fly function to each object. Now bird and plane can both fly. Note how the mixin allows for the same fly method to be reused by unrelated objects bird and plane. Create a mixin named glide mixin that defines a method named glide. Then use the glide mixin to give both bird and boat the ability to glide. So we're gonna let glide mixin equals we be gliding. And then, oh, no. You're passing the object. Actually, we can just do this, I think. Oh, no, we can't. That's only on objects. And then object, return, we be gliding. And then we need to use the glide mixin on the bird and the boat. Use closure to protect prototypes within an object from being modified externally. the previous challenge, bird had a public property name. It is considered public because it can be accessed and changed outside of a bird's definition. Therefore, any part of your code can easily change the name of bird to any value. Think about things like passwords and bank accounts being easily changeable by any part of your code base. That could cause a lot of issues. The simplest way to make properties private is by creating a variable within the constructor function. This changes the scope of that variable to be within the constructor function versus available globally. This way, the property can only be accessed and changed by methods also within the constructor function. Your get hatched egg count is a privileged method because it has access to the private variable hatched egg. This is possible because hatched egg is declared in the same context as get hatched egg count. In JavaScript, a function always has access to the context in which it was created. This is called a closure. Change how weight is declared in the bird function so that it is a private variable. Then create a method getWeight that returns the value of weight. Understand the immediately invoked function expression, IIFE. A common pattern in JavaScript is to execute a function as soon as it is declared. So yeah, we're wrapping the function here. So I think that's what does it. This is an anonymous function expression that executes right away, outputs chirp chirp immediately. Note that the function has no name and is not stored in a variable. The two parentheses at the end of the function expression cause it to be immediately executed or invoked. This pattern is known as an immediately invoked function expression, or IIFE. Rewrite the function, the function, make nest, and remove its call, so instead it's an anonymous, immediately invoked function expression. All right, so we get rid of this. Nice. Use an IIFE to create a module. An immediately invoked function expression is often used to group related functionality into a single object or module. For example, an earlier challenge defined two mixins. We have the glide mixin and the glide mixin. We can group these mixins into a module as follows. Let motion module equals this function, and we've grouped them all. Note that you have an immediately invoked function expression that returns an object motion module. This returned object contains all the mixin behaviors as properties of the object. The advantage of the module pattern is that all of the motion behaviors can be packaged into a single object that can then be used by other parts of your code. Here's an example using it. We're using the motion module glide mixin on the duck, so now the duck can glide. Create a module named fun module to wrap the two mixins isCuteMixin and singMixin. Fun module should return an object. So we're gonna let fun module equal this is so then here returning an object, and we have the is cute mixin, and then we have the is or the sing mixin. This is going to take an object. This is going to take an object. Clean this up a bit. Let's see here, object, sing, singing to an awesome tune. So we should be able to get rid of these now. There we go. That's it. That's it. Oh, man. We have done 435 out of 1,408 coding challenges. 5 out of 30 projects. 1 out of 6 certifications. Hello, Shy Pebble. I'm sorry. Dude, I'm sorry that it's over now. I hope that's what you're not like missing. Do. I'll be back tomorrow, though. Oh, wait. No, I won't. It's Thursday. I'll be back Monday. Monday, 1 p.m. EST. We'll be doing the next section, functional programming. Oof. Yeah, oof. I'll also be back later tonight, 8 p.m. EST, for some Clash Royale. I'll catch you later. Oof.